Good afternoon, everybody. Today, we're going to talk about the 2023 US Open Platinum level problem number 2. Good bitstrings. This is a very interesting question. The answer actually will turn out to be very short. So you have two positive strings, two positive integers, A and B, and you have a function which behaves like this. Essentially, it behaves like this. So if you have A and B, so if x plus y less equal, if x plus y less equal A and B, then what you do is if y divided by x bigger equal b over a, then x plus plus else y plus plus. Okay, so what they're asking is every time you create if it's a improves, which is if x improves, you label that as 0. If y improves, label that as 1. In the end, you get a string like this. The question is basically how many of those prefix of those, or the original string of the final string, is also represented by certain numbers. Okay, and then you want to calculate it in multiple cases. So if you look at this, what this means is if you draw it in 2 dimensions, okay? So if you have a number, which is a, b, right? So this is b and this is a, and you start from here. Initially you move x move 1, and then y move 1. As long as this slope is less than this slope, you continue move until you exceed, then you move x, right? Then maybe you move to like y like this. I'm just illustrating. Then you move x, and you move until you reach here or above. The prefix, the number of prefix, so-called good strings, is essentially equivalent of how many steps you take. So you just want to count, figure out how many steps you're taking. So how do I do this? So let's start with a simple number. Okay, let's use this function f(x,y) as the answer. Right. So let's start with something like simple. Let's say is x and y are the same. Okay. So in this case, my slope is 1, right? So I have xx. So I basically just go here, 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 and just keep going up, right? And I'm not drawing exactly to scale, but you got one. So you can count it. This is basically 2x minus 1. So that's very easy to count. So what if it's x equal y, if x and y are the same. Okay, so it's 2x minus 1. So now, if you then you can take a look of fx of 2x. Okay, very soon you will find out fx of 2x equals f2x of x. Okay, so now you're starting to ask you, then you do f x and x plus 1. you can find it out is this one actually does not equal to fx plus 1 and x. So you cannot exchange those things. But this thing actually you find out equal to 1 x plus 1. Okay. So or you can find it out equal to fx of 1 plus 1. So now, I mean, how do I find this? There's two ways you can do it. You can like do it in my drawing and trying to figure it out, or you can brute force it and just write a code to brute force what happens, and then and just try to verify your conclusions. Pretty soon, what you will find out. So this makes me guess is f x of y. When x less than y, that's equal to f x y minus x plus 1. So when x equal y, I know that is 2x minus 1, right? So when x is bigger than y, does that mean f x minus y of y plus 1? This is basically the GCD code, right? That's how we do the GCD. So that's my guess. Then if I plug it in, so I found out this is correct. Plugging in means if I just use a brute force way to code it and then try to verify it, I find out that this is correct and this word is not correct. This is not quite correct. It actually turns out is when x is bigger than y, it's less than 2y, then whereas x is bigger than 2y. I mean, x bigger than 2y. Then x bigger than 2y, this thing is correct. But in this particular case, you could draw it. You could draw it later. Right? So remember, when go here, because x is less than 2y, so you actually go exceed here, then you come here, right? Because the y is, right? So, I mean, the other way around. You go here, then you go up, you will actually exceed it. So in this particular case, you actually find out this is f x minus y of y. You have to plus this x minus y take upper bound plus 1. It's actually like this. So then this is correct, then this is correct. So now you actually derived just by looking at this and just after the class you can carefully draw those things, then you will find out exactly this formula, right? So it's frankly pretty straightforward if you think about it. So now you have this formula, then obviously you can then use, remember again, this is still very similar to GCD, right? If you want to use the GCD stuff, remember there is the standard way of doing GCD, right? Then you get a log and so use the standard GCD stuff. I assume everybody is very familiar with how to do this GCD stuff. Okay, so by doing it that way, then you basically get O of log x plus log y, right? So then you have n of them, right? So n of them. You have you have total t, right? So it's actually, you could run it actually quite fast by once you derive this formula. Again, I'll just write it here just for you guys, easier to understand. Fx of y equals to, when x equal y, this thing is 2x minus 1. When x is less than y, this thing is fx y minus x plus 1. You remove the small one from the big one. When x is less than 2, is bigger than y, but less than 2y, this is fx minus y plus this upper limit of x divided by x minus y plus 1, upper limit. So when x is bigger than 2y, then the reverse is true. That's 1. Okay. So that's how I derive it. Then this can be done in standard GCD as n log n, t log n complexity. So that's basically the answer for this question. It takes a while to derive this. You can derive it by drawing it on this 2D plane and really think about it. It started by thinking, when you use a simple case, right? When x equal to y, then you start to see this is basically a staircase going up. Then you can verify this by, code a brute force thing and then verify your equation is correct. So that's basically the answer. The result, once you figure this out, the answer is actually very short. It's like 20 lines of code, and then you're pretty much done. So that's the answer for question for this problem. Then next week, we will talk about the last problem of the US Open, which is triple chaos. After we finish this, then we're going to talk about last year's IOI problems. Okay, so for you guys who already, I'm sure you guys already did all those problems. You may not solve it. You can start looking at try to solve last year's IOI problem, right? So 2022 IOI problems. Okay, so there are 6 of them. So good luck, and I'll see you next week.